Hello, guys. Welcome to Ramta Solutions. And we're still continuing with my flu voice. I do hope, however, that you will be able to hear me. So today, in our fourth lesson of Grade 12 Financial Mathematics, we're looking at the third case study under future value annuity, where payments are made immediately and thereafter at the end of a term. Okay, so like we have been doing with all the cases, this is case one. No, this is case three. Like we have been doing with all the cases, we've been using the case of Lesedi, who's been investing 1,000 rand into her investment account, right? We've been using the case of Lesedi, who's been investing 1,000 rand into her account. So in today's case, Lesedi invests 1,000 rand on the day that she opened her investment account, and then 1,000 rand at the end of each year for 5 years. The question is still, how much will she have after 5 years if the bank offers her interest of 10% per annum? So remember, the case study is saying payment is made immediately and thereafter at the end of each term. So we have 5 years here, right? We have 5 years. So we have T naught, T1, T2, T3, T4, T5, right? Okay, T5. All right. So she is depositing this 1,000 rand immediately on the day that she opens this account. So this means she's doing that where? Here, right? She's doing that here. And then at the end of each year, so this is the end of the first year. This is the end of the second year, end of the third year, the end of the fourth year, right? The end of the fourth year, and the end of the fifth year. The interest was 10% per annum, right? The interest was 10% per annum. So now we are going to calculate how much she will have at the end of 5 years. So remember, we know A is equal to P into 1 plus I to the n. And let me remind you, this is an annuity because as you can see, these are equal payments and they are made at regular intervals, all right? They are equal payments made at regular intervals. So they qualify to be annuities. And because we are investing for a future time where you withdraw in the money, it'll be future value annuity. Perfect. So the money that she's getting at the end will be 1,000 that she deposited on T0. It was in the account for 1, 2, 3, 4, 5. All right. So it'll be into 1 plus 0.1 to the 5 plus another 1,000, which was in the account for 4 years. Let's see. This one here, let's see. It's 1, 2, 3, 4. Can you see that? To the 4. Now, as you can see, it seems it'll be now 1 plus 0.1 to the 3. Let's confirm the third installment. It's 1, 2, 3. Can you see that? Perfect. So the fourth will be, now you can see that there is a trend here. It'll be to the 2. And then the fifth will be to the 1. And then the sixth will be to the 0. Okay? Will be to the 0. Now, take your calculator and tell us what your final answer is. Also do the same. So I will say it's 1,000 into 1 plus 1.1 plus 1.1 squared plus 1.1 cubed plus 1.1 to the 4 plus 1.1 to the 5. Yes, I believe this is it. Okay, you guys will tell me when done. Okay, so I get 7,000. I get 7,715 rand and 61 cents. Okay, I get 7,715 rand and 61 cents. Okay, so this is what we are getting. Okay, this is what we are getting. Okay, now let's talk generally. Okay, we will talk generally. Let me copy this. We will not be talking generally. So let me copy this. Let me copy this. Okay. Now, we'll copy this. Not nice. Okay, let me paste it. So I'm going to say, repeating everything. So in place of the amount, I'm going to put X. Let me put X in place of the amount. I'm going to place X. And for 5 years, it's okay. But I want to say for N years. But I'm going to limit my case for 5 years. And then for I%, she invests at I%. It's okay. Okay. For N years, I will say for N years. So we using this. So I will say generally. So generally, if we take that case as it is, so let's say generally, Lesedi invests. Lesedi now, since we're using a general case, Lesedi is now any other person. Lesedi invest X on the day she opened her investment account, and then X at the end of each year for N years. How much will she have after N years if the bank offers her interest of I% per annum? So what we're going to do, I'm going to limit it to those 5 years because I'm going to limit it to those 5 years, but I'm going to generalize it for N years. Okay, I'm basically saying I'm going to limit my timeline for 5 years. Okay, so now we are saying Lesedi, this is now any other person, is investing X odd immediately on the day that you opening an account, and then at the end of each term, in this case at the end of each year, right, at the end of each term. And then what is the interest? The interest here is I, right? The interest is I. So how much will you have after whatever years? In this case we're saying N years, but I'm gonna limit it to 5. It'll be this amount was in the account for 5 years. So it is X into 1 plus I to the 5, let's work it like that, plus X into 1 plus I to the 4, this one here, plus X into 1 plus I to the 3, this is this one here, 1, 2, 3 indeed, plus X into 1 plus I to the 2, it's this one here. The 5th installment, it's X into 1 plus I to the 1 plus X into 1 plus I to the 0. Further simplification, we have X into 1 plus I to the 5, right? And then 1 plus I to the 4 plus 1 plus I to the 3 plus 1 plus I to the 2 plus 1 plus I to the 1, I'm not going to write 1, plus any number to the 0 is 1, so it will be X, right? It will be X. So if this was 4 years, this series was going to end with 4, or here we were going to start with 4 instead of 5. If it was 3, it was going to start with 3. Okay, perfect. Now, let's rearrange it. So rearranging in ascending order. Okay, rearranging in ascending order. In ascending order, we have a equals x plus x into 1 plus I plus x into 1 plus I to the 2 plus x into 1 plus I close to the 3 plus x into 1 plus I to close to the 4 plus x into 1 plus I close to the 5. Right? So this looks like a geometric series. By now you know it's a geometric series, and its first term is x. Its common ratio, as you can see, x into 1 plus I close all over x is 1 plus I. So I'm going to say let Sn be f, and we're going to call n, we're going to call it n, we're going to call it n, because I want us to find the general what is this? I want us to find the general formula, or the formula. Okay, I do see, however, that our n, when you look at it here, our n, though the investment was for 5 years, the number of installments, remember in the previous videos we said n here represents the number of installments. So as you can see, because this is a series, there are 6 terms. Look at them: 1, 2, 3, 4, 5, 6. So what is our n? Our n is basically 6, but we're going to look at it in a few minutes. Okay, in a few minutes you're going to understand why I was always saying in the previous videos that you should not say this is. You will understand why I was saying you should not say this is number of years. Rather say it's number of installments. Okay, rather say it's number of installments. Okay, perfect. So let's see. Now we're going to say Sn equals a into r to the n minus 1, simply because radius will be greater than 1. All right, and we said let's call this f. Okay, we said let's call this f. So I'm going to take it like that, f, and a. What is our a? Our a, as you can see, is x into what is our thing? What is our r? It is y plus I to the n. Okay, to the n minus 1. I'm going to leave it as n, but I want you to be careful. All over r minus 1. Okay, all over r minus 1. So, oh sorry, not r minus 1. We said r is 1 plus I. 1 plus I minus 1. Okay, it's okay to leave it like this, but you need to be careful. This represents the number of terms. Okay, this represents the number of terms. If we say n is basically, I remember in the last video I said we normally say it is number of years times the frequency that your interest is quoted. So when you have a situation like this, you will say if your frequency is per year, it will be number of years times 1, which will be, in this case, it will be 5. So it seems like your n will be 5 times 1, meaning your n is 5. But it doesn't look like it here. Can you see that? It doesn't look like it here. So what does it mean? We need to add a 1 here, and it'll make sense. Okay? We need to add a 1 here, but I will tell you how we get to this. Okay? I will tell you how we get to this. So let's continue, and then we will say f equals x into 1 plus I to the n minus 1 all over I. This is the formula that you know, but I am paying special attention to this n. Okay, I am paying special attention to this n. So this n, I will say to you, note number of installments. Okay? Note number of installments. Do not confuse it. Note number of installments. So, if you prefer to say n is number of installments, it's basically number of years times the frequency that your interest is quoted. It'll be okay, but you need to be careful. So you can leave it like this, or alternatively, you can say f is equal to x into 1 plus I to the n plus 1 minus 1, okay, all over I, okay, all over I. Now, I'm going to make a remark on this n. For this n, it'll be number of years, okay? It'll be number of years times frequency of interest, okay, times frequency of interest. What I mean by frequency of interest, I mean the number of times that your frequency is quoted. If your frequency is saying per month, your frequency, it'll be times 12. If it's saying per week, it'll be 52. If it's saying per quarter, it'll be times 3, just like that. Okay? So this is the formula that you need to be aware of. So whether you use it in this way or use it in the normal way that you know, you will still be okay. So let us verify these formulas. Okay? So let's verify these formulas. I will begin with 1. I'm verifying f equals x into 1 plus I to the n minus 1 all over I. Our x, which is the installment, is 1,000. Our n, remember, normally when we talk n, I like saying to you, do this. Say your n, especially for a case like this, say your n is last minus initial, okay? Last minus first plus 1, okay? So let's go to the timeline. When was the last payment made? On the 5th year. So our n, look at it now, our n will be 5 minus, when was the initial payment made? At the beginning, at time 0, plus 1. What is this? This is 6. Can you see that? This is 6. And then what is our I? Our I is 0.1. Let's confirm this. Okay, let's confirm this. So, we will say f equals 1,000 into 1 plus 0.1 to the what? We said our n is 6. All right, to the 6 plus, or minus 1, sorry. Minus 1 all over 0.1. Let's see. So when I plug this on my calculator, I get 1.1 to the 6 minus 1. Okay, I'm getting 7,715 rands and 61 cents. Let's confirm if this is the same as the one we got when we were calculating manually. 7,715 rands and 61 cents. Can you see that? So this long calculation has been simplified into a formula. Okay? Has been simplified into a formula. Can you guys see that? It has been simplified into a formula. Now, let's verify the second formula. We said f equals x into open 1 plus I close to the n plus 1 minus 1. Okay, over I. So, I said with this one, you will consider your n as the number of years times the frequency of interest. So, here, what it means, first and first, our x was 1,000. Our X was 1,000. Our I was 0.1, which is 10%. Our N, what is it? Our N is number of years times the frequency. How many years is this investment for? It's for 5 years. So it'll simply be that. It'll be 5 years. Okay? Now, check this out. So this is 1,000 into 1 plus 0.1 to the 5 plus 1 minus 1 all over 0.1. Agree with me that this is power 5 plus 1 is similar to 6, right? We are still going to get 7,715 rands and 61 cents. It is the same thing. Okay? It is the same thing. So these are the formulas. Now you understand that when you do financial mathematics, be careful of your end. So let me summarize this problem here. We have two cases, or we have two formulas. F equals X into 1 plus I to the n minus 1 all over I. Always works. And then we have X into 1 plus I to the n plus 1 minus 1, of course, minus 1 all over I. So we say this one, your n is last minus initial plus 1. But for this one here, your n is number of years, right? Number of years times frequency. When I say frequency, I'm saying frequency of your interest, if it's per month, per quarter, and so on. Okay? As simple as that. So you choose whichever you prefer, you will never go wrong. However, I always advise that you guys take this one, because you don't want to be claiming formulas, right? When you use this one, you will still get your full marks. Even when you use this one, you're still getting your marks. Okay, so this is the case study that we were dealing with today. So it's a wrap. See you next time, and bye.